Good morning, good afternoon, and good evening to all of those joining today's webinar. I know we're at the top of the hour, and I'm sure people will be trickling in, so we have just a few things to go over to get started. My name is Rachel Lieberman, and I am currently the Global Forensic and Toxicology Marketing Manager at Waters Corporation in our clinical business unit. I will be your moderator today, and so the overall title of today's webinar is Uncharted Territory: Innovative Approaches to Novel Benzodiazepine Analysis in Toxicology. So before we get started, I would like to go over a few housekeeping items. As you'll see here on the screen, we have a screenshot of what you guys are viewing in the webinar room. Please use the Q&A box to ask any questions throughout the webinar. We will be having a Q&A session concluding the presentation where we'll answer any questions asked by both speakers. In the center, you will see the slides for the presentation. And then below the slides, you'll find a resource list with any additional information and applications related to this topic. On the right-hand side, you will find the speaker bios and a survey. So please feel free to fill out the survey at any point during this presentation. We will be conducting a few polls throughout the presentation to engage you in the audience and to find out some more information. If at any point you are unable to see these windows, please refer to these icons at the bottom of the page to expand them. So first, I'd like to introduce today's speakers. We have Emily Lee, who is an application scientist at Waters Corporation, and she's part of the global team dedicated to the development of applications and analytical solutions for forensics and toxicology. She's gained experience in multiple different Waters mass spec technologies, and prior to working at Waters, Emily has experience working in forensic toxicology laboratories with high sample turnover and fast turnaround times. She's involved in many aspects of day-to-day laboratory operations, including sample extraction, analysis, method development, and validation, analytical troubleshooting and reporting. And she also has a master's in forensics science at the University of Huddersfield. Our second speaker today is Boris Lazarov, who has a bachelor's in chemistry and a master's in organic chemistry that were both completed in his home country of Bulgaria. And he has extensive experience working in food and environmental labs. Basically, in 2021, he joined the University Hospitals of Leicester as an analytical chemistry specialist. And in this role, he has been responsible for the development, validation, and implementation of novel analytical methods in both the postmortem and clinical teams. So his work is very pivotal in delivering accurate and reliable results to support the relevant toxicological and clinical investigations. So before we get started and we turn this over to Emily, as I mentioned, we have a few poll questions. So here's our first poll question. Do you currently use benzodiazepines in your region, or C benzos, excuse me? Yes, no, or unsure. So if you go ahead and select one of these answers, we will have the results here shortly. So go ahead and submit. A few of you guys are awake this morning. There we go. Getting a few coming in. So almost all of you guys are seeing benzos in the region. So this is a very applicable topic. And to follow up on that question, are you currently testing for benzos? Yes or no? Should be pretty straightforward. Or have testing methods. Give you guys a few seconds to answer this. There we go. All right, another 5, 4. Nice. Got a good number of answers here. All All right, so majority of you guys are already testing for benzos. There's about 5% of you or so that have not. So hopefully this can help you to enhance what you guys are doing and give you some additional resources. And then the last question is, if you are testing, what type of benzos are you testing for? Do you test with the traditional benzos? Are you looking to expand for designer benzos? Do you look at both? Or because you're not obviously testing, not applicable? If you guys can answer this for us, that would be amazing. And then we can show you some results, and then we can get into these two methods. And you can actually hear from the speakers. And I will moderate in the back. A couple more. 10 more seconds. 3, 2. All right. Okay. So most everything right now is on traditional benzos only, or both. So that's interesting, where I guess the methods kind of include everything. So with that, hopefully, Emily and Boris, that gives you guys some insights as to discussions with your guys' methods. And I'm going to turn it over to you, Emily, and let you take it away.
Thanks, Rachel. So hello, as Rachel said, I'm Emily Lee and I'm an application scientist at Waters. So today I'll be presenting a rapid and comprehensive UPLC MSMS method for the analysis of benzodiazepines in urine. So for this presentation, I'm going to cover the importance of benzodiazepine analysis, describe a simplified mixed mode SP procedure, which can produce accurate and precise quantitative data, and also the chromatographic method, which is rapid, reproducible, and achieves baseline separation. So benzodiazepines are important toxicological drugs, and they are widely prescribed for both neurological and psychiatric disorders. These can include anxiety, sleep disorders, and epilepsy, but they are also highly abused. They can cause side effects such as drowsiness, fatigue, amnesia, and they have a high potential for addiction. They've been reportedly abused to reinforce the opioid effects, counteract the effects of stimulant abuse, or to perpetuate drug-facilitated sexual assault. So since the mid-2000s, there has been many new designer benzodiazepines which have been reported, and these do continue to emerge. With these new designer benzos, the potency and the risk is largely unknown, and therefore they are causing a public health concern where they are being used. A further concern is that designer benzodiazepines have been found to be being used to make counterfeit tablets of commonly prescribed benzodiazepine medication. This could be unknowingly taken by individuals that are legitimately prescribed this medication. Therefore, an analysis method which includes both traditional and designer benzodiazepines is required. So at Waters, we've developed a comprehensive method for confirmatory and quantitative analysis for both traditional and designer benzodiazepines in urine samples. This is a full solution from sample prep to chromatography and MS analysis. And on this slide, we've just listed a summary of the systems and chemistries which are involved, but I will go into these in more detail in the coming slides. So we'll start with the sample preparation. We've employed a simplified mixed mode sample extraction procedure, which uses Oasis MCX microelution plates. So firstly, 100 microliters of the urine sample was added into the wells of the plate, and this was followed by 100 microliters hydrolysis enzyme mix and 20 microliters of an internal standard mix, which was at 250 nanograms per mil. This was then mixed with several aspirations and then left to incubate at room temperature for 10 minutes. Following this, the samples were acidified by adding 200 microliters of phosphoric acid. This again was mixed with several aspirations before being loaded directly onto the sorbent of the plate under vacuum. Following this, the sample was washed with 200 microliters of 20% methanol, then eluted with 2 times 25 microliters of 50-50 acetonitrile methanol, which contained 5% strong ammonia. Finally, all samples were diluted with 150 microliters of 2% acetonitrile and 1% formic acid. The transfer steps have been minimized by both the enzymatic hydrolysis and sample pretreatment being performed in the wells of the extraction plate. And then further, this procedure has been simplified by eliminating the condition equilibration steps and using a single wash step instead of 2. So here we have the UPLC conditions, which were used with an Acuity UPLC I-class FTN and an Acuity UPLC BEH C18 column. The mobile phase A was 0.1% formic acid, with mobile phase B being 0.1% formic acid in acetonitrile. The starting conditions were 2% mobile phase B, which ramped up to 90% in 3.5 minutes, with a total runtime of 4 minutes and an injection-to-injection time under 5. This resulted in a rapid chromatographic method which achieved baseline separation of all the analytes included. On this slide, we've got the MS conditions. The UPLC MS-MS method was applied in conjunction with a Waters TQS micro mass spectrometer, which was operated in electrospray positive mode. The cone voltage and collision energies were optimized for the individual compounds. So here we have a list of the 26 traditional and designer benzodiazepines which were included in this method. Stable isotope labeled internal standards were used for all of the compounds except for 8, where the internal standard either interfered with the quantitation of one of the other compounds or it was not readily available for purchase. In these cases, a surrogate internal standard was used for these compounds. So within this method, there were 2 MRM transitions which were monitored for each of the compounds here, and then a single MRM transition was monitored for the deuterated internal standards. So now we've described the method, we're going to have a look at some of the results. So as I previously said, the chromatographic separation was performed on the Acuity UPLC BEH C18 column, and this had a total runtime of 4 minutes. So on this slide are the chromatograms of the quantifier ions from a urine sample which had been spiked at 50 nanograms per mil for all of the 26 compounds. The earliest deleting compound is 7-aminoclonazepam at 1.55 minutes, and the latest deleting compound is diclazepam at 3.26 minutes. Care was taken to ensure that there was no interferences between any of the compounds or internal standards, and baseline separation was achieved for all 26 compounds. The figure on this slide shows the mean extraction recoveries of the entire panel of benzodiazepines from 6 different lots of urine. The mean extraction recovery was 86%, and all compounds had recoveries greater than 75%, with coefficients of variation less than 10%. These highly efficient recoveries across the different matrix lots and the less than 10% CVs demonstrate that the sample preparation procedure was robust. The matrix effects were also evaluated using 6 different lots of urine. The mean matrix effects for the benzodiazepine panel are shown in the figure on this slide. Ion suppression was observed for the majority of the compounds in this panel, with the effects ranging from 30% ion suppression for chlordiazepoxide to 35% ion enhancement for alpha-hydroxyalprazolam. The standard deviations were less than 15% for all compounds, with the exception of 8-aminoclonazepam. This indicates that there is consistent matrix lot-to-lot performance. The matrix effects were compounds, except for pyrazolam and fluoromazolam. These two compounds did not have a deuterated internal standard which was readily available, and therefore a surrogate internal standard was used. The guidelines recommend the use of a stable isotopically labeled internal standard when available, so therefore for these two analytes it may be appropriate to further investigate the choice of surrogate internal standard. Eight-point calibration curves were prepared and extracted across the range 5 to 1,000 nanograms per mil and analyzed over 5 days. With the exception of 7-aminoclonazepam, 7-aminofluonitrazepam, 8-aminoclonazolam, fluoromazolam, and pyrazolam, which had 7-point calibration curves across the range of 10 to 1,000 nanogram per mil, which was due to the limit of quantitation determination. The calibrators were required to be within plus or minus 15% of the nominal value, with the exception of the lowest calibrator, which was required to be within plus or minus 20% of the nominal value. And 75% of the calibrators were required to meet this criteria. For all compounds in the panel, these criteria were met, and the responses were quadratic with a 1/x weighting applied, and R-squared values which were greater than 0.99. So the quality control samples were prepared at 4 concentrations which spanned the range of the calibrators. These levels were 15, 75, 200, and 750 nanograms per mil. These samples were again analyzed over 5 days, with 6 replicates of the QC samples prepared and extracted each day. Similarly to the calibrators, the QCs were required to be within plus or minus 15% of the expected value, with the exception of the lowest QC level, which was required to be within plus or minus 20% of the expected value. Here we have the inter-day results from the 5 days. This testing resulted in coefficients of variation less than 10%, and the majority of the compounds were within 10% of the expected value. So to conclude, SPE cleanup using Oasis MCX microelution plate efficiently and accurately extracts the panel of 26 benzodiazepines from urine samples. The use of the Acuity UPLC BEHC18 column results in rapid chromatographic separation of all analytes in the panel. The Xevo TQS Micro mass spectrometer provides the analytical sensitivity and the dynamic range capabilities required for the analysis of benzodiazepines. The combination of the sample preparation method, UPLC separation, and MS-MS detections results in a complete method for the comprehensive analysis of benzodiazepines in urine, including new designer benzodiazepines. For full details on this method, the application note is available on the Waters website, and it is also linked here on this slide. I would like to take this opportunity to thank my colleague, John Danisau, for his support and guidance during this project. Thank you for your time and attention today. I'm happy to answer any questions, so if you just place those in the chat, or if you'd rather, you could send me an email if you want further information. Thank you.
Thank you so much, Emily, for that quite insightful talk. And thank you all for coming here and joining today. Today I'm going to talk about the development and validation of a confirmatory quantitation method for benzodiazepines in post-mortem blood. Throughout the presentation, we're going to look at our panel, just a brief overview on the benzos and the analytes that we've chosen for this method, and the method itself. Then we go through the validation experiments before I do just a quick summary at the end. Benzodiazepines, as most of the attendees in this webinar probably know better than me, are one of the most abused substances in the UK. Characteristic trait of the benzodiazepines is they are co-abused alongside mainly opiates, alcohol, and cocaine. And for our panel, we chose some traditional benzodiazepines alongside some designer benzos. From traditional, we cannot go without the diazepam and its metabolites, diazepam also known as Valium, by far the most frequently detected by our screens analytes of this drug class. Also chlordiazepoxide, often prescribed in the UK, alprazolam, also known as Xanax, a triazole benzodiazepine that's quite a bit more potent than diazepam, up to 10 times to the best of my knowledge. And also we included midazolam, which is also more potent than diazepam, albeit not as much as alprazolam. And it's also used as an anesthetic in intensive care units and end-of-life care. Alongside these traditional benzos, we've also added some novel psychoactive substances of this class, bromazolam, etizolam, and the fluorinated derivatives of alprazolam, bromazepam, and bromazolam. And of those, bromazolam has gained quite a popularity in the last few years, and we are quite frequently detecting it, a lot more frequently in our region as opposed to the other four. Given the difference in potency, we needed to cover different ranges for the different analytes. Diazepam and its metabolites, alongside chlordiazepoxide, wanted to get up to about 1,000 nanograms per mil, while for alprazolam and the NPS benzos, we wanted to go as low as 1 nanogram per mil. With these requirements at hand, we started the method development, and starting from the extraction, the key word here for us was simplicity. Just a simple protein precipitation, 100 microliters of sample, crushing with acetonitrile, combined with the available at the time deuterated equivalents of our analytes, so there wasn't 4 of them. Quick vortex mixing, centrifugation, we transfer the supernatant into the collection plate and straight into the analyzer, which in our case was a QETI Class Plus fitted with a sample organizer and coupled with a Xevo TQXS tandem quadrupole with mass links for the and target links for the data processing. Starting back to front to back rather, with the LC method, we start from a very generic screen method, which was developed by one of our principal scientists, and tweaked a little bit to get better separation, quite decent for our benzodiazepines, albeit I must admit it's not as comprehensive as what you've seen on Emily's slides, but nevertheless, a respectable 12.6 points per peak without pushing too much the dwell times for each transition. Further on the LC method, the total runtime was 5 minutes. We used the normal C18 column, water spiked with formic acid for our mobile phase A, methanol spiked with formic acid for the mobile phase B, and the wash solvent. We also ramped up the column temperature a little bit, up to 50 degrees. That did lead to improvement in peak shape. If methods permitting, analyze permitting, I would always recommend ramping up the temperature a little bit. Obviously not go as high as, I think 65 degrees is for this particular column is the threshold, so always look at that as well. And we used an automated solvent strength reduction. What I mean by that is with the analyte eluting at around 40% mobile phase B, the supernatant was predominantly acetonitrile, so we needed to dilute this with mobile phase A. Is what we've chosen for dilution. We decided to do this in the autosampler itself to keep the extraction as simple as possible and also have a more reproducible solvent strength reduction. And we use the auto addition column in Massling. So if you're using Masslings, this is a great way. You can also do some sample prep again within the autosampler if you decide it, or if you need to spike something on the go. With the 10 microliter needle, I think it will be pretty much okay to go as low as 1 microliter. But back to the method, in our case, we were drawing 4 microliters of sample, as shown in the example in this case in rack 9 in row G. and then the needle goes through the whole washing procedure to avoid any contamination, and then we use the auto addition column to then add 6 microliters of the mobile phase A, thus diluting in the needle and injecting straight into the instrument. The mass spectrometer, we're working in positive mode with those nitrogens in these drug structures begging to be protonated. There's no other way to go about it, really. And on the slide, you can see the different temperatures, the capillary voltage, and the desolvation gas flow that we used. For each analyte, we wanted to get at least 3 transitions, 1 quantifier and 2 qualifiers. This was not possible for flubromazulam. And one thing to highlight is that for diazepam and no diazepam, we observed overloading of the detector at the top end of the calibration range. So that's why we decided to do an isotopic dilution using the carbon-13 isotope for the parent ions as opposed to the carbon-12. With that, our method was set, and we went through the validation. Now, obviously, using a protein precipitation method, we did observe quite a bit of ionization suppression, going as high as 47% for chlordiazepoxide, and that translated into our recoveries, which, albeit decently, ranging between 50 and 77%. Again, we cannot say they were as good as what you've seen on Emily's slide with the cleanup process. That being said, we're extracting all our calibrators, and we're confidently seeing the bottom end of the calibration curve, so it was not a problem in our particular case. In terms of the linearity, we analyzed 6-point calibration curves, spiked in whole serum, and used a weighted 1/X linear model. Our threshold accepted for acceptance criteria was 0.98, and all batches were well within, well above this value, with average correlation coefficients for the different analytes above 0.99. For the bias and precision studies, we used commercial control material, recipe clean check, serum control for benzodiazepines for the traditional benzos. For the designer ones, at the time of the validation, there was no commercial alternative. That's why we prepared one in-house from using standards from different suppliers than the ones we use for our calibration curve. As you can see from the table, the majority of the analytes were well below the 10% for the bias, while there were a couple of exceptions with alprazolam and temazepam, but just slightly above 10% and well below our threshold of 20%. For the interassay precision, measured as coefficient of variation in percentage, most of the analytes were again well below 10%, with bromazepam being just at the 10% mark. And for the intra-assay precision, again, all of the analytes well below 10%. We also analyzed some post-mortem case and EQA samples. For the EQA, we used the LGC tox distribution, samples benz and benz B. It's worth noting that chlordiazepoxide, bromazolam, and the fluorinated benzos were not part of any of those samples. And etizolam, although it's part of the benz B sample, there was only one lab at the time who were reporting etizolam. Therefore, the assigned values sometimes made no sense because they were way far off the spiked value. Nevertheless, for the remaining analytes, there was acceptable performance from the EQA, and the charts at the bottom are for alprazolam. We also did a paired T test for the postmortem case samples, whereby we compared these methods with, at the time, our current method for benzodiazepines for the traditional benzos, and the results from the referral lab where we were sending our designer benzos. The statistical analysis showed no significant difference between the methods, and whereby there were individual results where there was a bit more difference between the methods, it didn't lead to changing interpretation. We also measured the stability of the extracts, whereby we store them in a freezer at -20 degrees in a 14-day period. The traditional benzos were stable for the full 14-day period. However, the designer benzos showed lower stability, with the majority of them being stable for 3 days, and flubrorazepam only for 1. Neither the matrix nor the deuterated analyte equivalent showed any significant interferences with the analytes. Both of them with signals for the analytes well below 10% of the lower limit of quantitation. And we also checked the potential interferences from some commonly prescribed or abused drugs, the obvious ones, opiates, cocaine, and also other benzos and other classes, drug classes. And as you can see from the graph, there was barely any change due to their presence. Before I wrap the presentation up, we tested a couple of more parameters, carryover, tested by analyzing 2 blanks after the top calibration standard. And again, there was no observed carryover from within the method, as all results were less than 10% of the lower limit of quantitation. Speaking of the lower limit of quantitation, confidently validated 10 nanograms per mil for the diazepam, its metabolites, and as well as for the chlordiazepoxide. And we also validated 1 nanogram per mil for prazolam and the designer benzos, as well as, to be honest, for midazolam as well. However, for midazolam, such a low limit of quantitation posed some practical issues with reporting our clinical samples. That's why we decided to raise it at 5. In summary, we developed and validated confirmatory quantitation methods for 12 analytes, both traditional and designer benzos. We used a simple extraction, just protein precipitation, and employed automated solvent strength reduction within the autosampler. And then we also used isotopic dilution for diazepam and all diazepam to extend the total linearity of the panel. And before I hand you back to Rachel, just wanted to say a few thank yous. Big thanks to Laura and Kate for their support, as they were my supervisors throughout the whole project. And a massive thanks as well to the whole toxicology team in special chemistry in the University Hospitals of Leicester, as without them, I wouldn't know where pipettes, Eppendorfs, or anything is really. And last but not least, thank you to Adam and Rachel for facilitating this talk and to making the whole experience very enjoyable and very smooth for me. And with that, thank you so much for listening, and I'll hand you back to Rachel.
Thank you so much, Boris and Emily. Those were great, really great presentations and details about the specifics that you guys have done in your different matrices. And so we have one kind of final last poll that we'd like to ask you guys. And while you guys are thinking about your answer to this poll question and generating some ideas about what you just heard, please feel free to also, fill in any questions that you have. You've got the analysts here that have done all this work, and they're more than happy to share and help with that. So the question that I'd like to ask, they're just, since you've heard about this, and I know a lot of you guys are already running benzos, but would you adopt these techniques in the future? Or take kind of what you've learned from here and use it in your laboratories. So we've got a couple of responses here. Yes, definitely, maybe need some more information or not interested in this time. If you could just please fill that out, that'd be great. We appreciate it. Also, give you guys a few minutes for that, and then we can go into our question and answer session. So please feel free to submit those questions now. And we do also have that survey as well. So thank you. Give it another 20 seconds. All right. Okay, so a good number of people that are interested, but then others that still need some additional information. And so for those of you that maybe aren't so sure or wanting additional information, please feel free to ask us questions to see exactly what it is that's there. Obviously, validation is important, and a lot of those things, how it would fit into your laboratory. So with that, I will put up this next slide here, which will take us into our question and answer session. So, Emily and Boris's email address is listed here. So if there are any questions that you guys want to follow up with, or that we don't have time to get to today, you can reach out via these emails here. But to kick off our question and answer session right now, I do have a question. And this is actually for both of you. So one of the things is, obviously you guys have discussed these methods. I think, Emily, you have a few more compounds than Boris, you did in the postmortem method. But if someone has a new benzo or designer benzo that they'd like to add to this method, how would you recommend they would go about doing this and providing that information?
So I actually had to add quite a few, as I was going on, because with delivery of standards. So I would recommend, if you've got the standard and you want to add it, you infuse it into the instrument so you can optimize the cone voltages and capillary energy, and then run it on its own to get the retention time. And then you can literally just add it into the mix from there and just check that it does go through the whole sample preparation efficiently. But from the results, it seems all the benzos do. So I don't see any problem with adding more.
Boris, do you have any comment on this?
Yeah, basically the same. The first thing that you want to do is, especially if you've got a big panel like Emily's, you don't want to start inventing the wheel from scratch, because you will have to validate everything. So the first thing that you probably want to do, just tune it, add it to your mix, run it on its own to see where it comes out. As Emily said, if you want to retune it at the correct gradient and go very OCD on it, happy days, go for it. But as I said, don't try to reinvent the wheel, because it's a different thing when you have to validate just one analyte and when you tweak the whole method, and then you have to validate for every analyte again, everything. Just the sheer amount of data in the current times is, just too much. So try simple at first, and if it doesn't work, then think about whether you actually want to add it or whether you want to just have it as a separate panel, for example, as well, if it doesn't work within the same method.
Great. Okay. I think that's really insightful. Thank you, guys. So we have a question here from Jason. So is there any investigation into any other column stationary phases aside from the traditional C18?
I didn't do any. We just went with the C18. It's like a gold standard for tops. So
yeah, no, same here. I think for the benzos, there's nothing that cries out specifically about them that would make them unsuitable for C18. I think that in theory they're hydrophobic enough, and you usually get a good separation. It's not like morphine, for example, where you will usually, if you run it on a C18, first you'll barely be seeing a peak, and second, it will be very, very early, almost no retention there. Same for the glucuronides if you're running them as well. So I think there's no reason why you would use something else than C18, and that's why we never even looked at it from that perspective.
Gotcha. That makes sense. And I think to tie into some of the methodology, and this is more on the sample prep side, but we have a question here from Joanne who's asked, how long roughly would the SPE method take for someone to prepare approximately 20 samples?
That's me, yeah?
Yes, that is. Sorry.
I didn't want to just jump ahead. So it would be easily automated. However, I didn't use any automation other than a multi-channel pipette. So for about 20 samples, it would take about an hour to an hour and a half to do the whole sample prep. But if you had automation in there, it would be way quicker.
Yeah. And that's
including the incubation as well.
Right. And this is using a plate, right? So the plates can hold up to 96 samples, right?
Yeah. And it's like, as I said, everything's done in those plate wells. So if you did have an automated sample prep system, it would be easily integrated into that.
Okay. And another question, Emily, to follow up slightly different, but it's more about like long-term stability of the samples. So Boris mentioned that he had some found that with the designer benzos, the stability wasn't so great. Some of them was only a day. Did you see the same issues or concerns in the urine samples?
We didn't do full stability studies, but I did do some reinjections from samples that had been sat on the instrument, and I didn't see any decrease over a couple of days, but I can't speak to it fully because I didn't do any full studies about that.
Gotcha. Okay. We got some good questions coming in. Thank you guys for all of these. So another question that we have here is, it kind of ties into this. And maybe Boris, you can shed some light on this, but is there any speculation as to why the novel benzos had such a decrease in the stability compared to the traditional? Do you think it maybe has to do something with the fluorinated compounds is not as great in the extraction solvent?
Possibly. I can only give it to the matrix, and then obviously the structure of the sample. Obviously, we're only doing a protein precipitation, which means that our extracts will be quite dirty to start with anyway. But again, it would only be a speculation without having to go through the chemistry of it. If you are concerned that you will have to leave samples and extracts, I think the easiest way is just to do a cleanup. And nowadays, especially if you've got, for example, an 100+ with extraction plus, I'm sure it's not going to take that long anyway. If you want the throughput, then and you're sure that you're just going to analyze the samples, and then if you have to reinject them, you still got that one day, then again, you can just go with a simple protein precipitation. It all depends on what you need, and I think that's the main thing you need to go from.
Gotcha. Okay, sounds good. And so, have a quick question for Emily here. So, I'm not sure if this was mentioned in your method. I don't believe it was, but do you have, what kind of glucuronidase reagent was used with the urine method?
It was B1 beta glucuronidase from Cura Biotech. It is in the app note full, but that's what we used. And as I said, it was for the benzos, it was 10 minutes at room temperature. So it was really handy.
Okay. Yeah, and that the QR code is in the slides that are here, but it is also that resource, the app note is in the resource list. So you should be able to have access and download that specifically as well, that was recently published. And so I guess this is a question for both of you as I'm going through this. So it's interesting because obviously, both of you guys are in the UK, and based on regions, people are going to see different types of benzos, whether they're in the Americas, Asia Pac, Europe, and so forth. And so, how did you select the novel benzos? Was it based off of the prevalence in your area? Was it based off of what samples were available or standards were available? And just kind of how do you determine what that is?
We went through scientific literature to see which were the most common designer ones, which were being mentioned recently. So we didn't go for like the really new novel ones that were starting to emerge. We sort of went for a mix of older ones that were really prevalent and then like maybe some newer ones that had become more prevalent. That's how we did it through the literature. And then it's hard because you want to pick them all, but you can't. So.
Mm-hmm.
Yeah, on our side, it was literally what we were detecting on our screens. And at the time, I think the fluorinated, we are detecting them every now and then. I think atezolizumab had a big spike in the UK. From all I know is still a big thing in Scotland, while bromozolam, as I mentioned in the presentation, has picked up quite a bit. But in our case, as obviously we're a routine lab, we just try to quantify whatever we're seeing on the screen. So we think that it's going to be beneficial to bring in-house and quantify.
Okay, great. Yeah, so we have another question. Actually, this is little bit more about ion suppression for validation. So does the ion suppression from the simpler lipid crash extraction cause any issues and differences in concentration if the samples have gone through more than one analysis?
So is basically they've been extracted and that they've been run a few times.
Yeah. Yeah.
Well, given that we had we did in rejection reproducibility as well, so we did reinject them a few times. Probably should have put a slide on that as well. We didn't see any change in responses or anything that's not being covered by the stability to start with. So as far as I know, there wasn't an effect. But again, if you're concerned about that, it probably is best if you actually check it during the validation.
Yeah, yeah, that definitely makes sense, just to ensure if that's there. And another question for you, Boris, with regard to the novel benzos, when you did your stability, did you investigate this in plain or preserved blood?
Always in plain blood. We're not using preserved blood for benzodiazepines, so it was the transition was like for like. Yeah, including for this. We didn't do any further studies because in our high throughput lab, we don't need to keep around samples for more than 3 days anyway. So yeah, that there wasn't there was no need for further investigation. But it's a good idea, and once I get some free time, I will definitely look into that. Thank you.
Okay. Yeah. No, that sounds interesting. And then the other thing is you mentioned a screening method. Was that run by a QTOF or a different method?
Yeah, it was still a triple quad. If you mean the one that we started from, it was just an LC method that was run on triple quad. As I say, it was just a project that one of our principal scientists was doing for a master's, and then we just started from there. And I think it was a good starting point anyway.
Okay. And then it looks like, we've got one more question listed here, but if you have more, please go ahead and ask them. We really appreciate that. And so this may be a question for Emily, and if not, Emma, I can probably answer this as well. But have we looked into any designer benzos in hair samples?
I haven't done any work with hair, but I don't know if anyone else has. You probably know better than me, won't you?
I don't know, Boris, do you guys look at hair samples at all in your lab?
No, not at the moment, I'm afraid. When it comes to post-mortem, we're basically looking at blood, we're looking at tissues, sometimes vitreous, and urine, but not hair yet. Not yet.
I will say I do know that we are working on a more comprehensive drugs of abuse panel in hair from one of our application scientists that we hope to have completed in the next month or so. And that may have some benzos and designer benzos in that particular method as well. So be on the lookout for that. It kind of ties into maybe wrapping up this session, since I don't see any more, is we are having a few more webinars that are coming up. One of which will be on drugs of abuse in hair later this year, so keep an eye out. We also will be having additional ones, so you just keep your emails open and look for everything. So before we get too far ahead, I do want to thank both Boris and Emily for your time today. I think that was really insightful. The questions were great, and I hope you guys learned some new information today about how you can go forward with these methods. And if there is no more questions, I want to thank you all for your attention today. Make sure if you get a chance, please fill out the survey. And we look forward to seeing you virtually soon. Thank you.
Thank you.